All right, so let's look at an example of a two-sample mean comparison test. Okay, let's read through this. It says, test the claim that the two samples described below, here's sample 1, here's sample 2, appropriately named N1, X bar 1, S1, N2, X bar 2, and S2. Okay. The two samples described below come from populations with the same mean. That would be the null hypothesis. Assume that the samples are independent, simple random samples. Test the alternative hypothesis that the first population, this one, which is associated with mu1, while this one is associated with mu2, okay? Test the alternative hypothesis that the first population has a larger mean at the alpha equals 0.01 level of significance. Then confirm your conclusion with a confidence interval. Okay. All right, so step 1, we're going to state the null and alternative hypotheses. Null hypothesis is going to be that mu1 is equal to mu2. And the alternative hypothesis is that the first one, mu1, has a larger mean. So that's greater than mu2. Okay? And so this is a right tail test because we're doing a greater than. So this is a right tail test. Okay? Step 2, we want to identify all of our statistics here. So, well, they're right here. You know what? I don't have to write them all out again. They're right here. But you know what we can do is we can go ahead and identify our alpha, which is 0.01. We can also identify our degrees of freedom. Now, let's pause here for a second because we've never done this one before. Degrees of freedom. So there are actually many ways of identifying degrees of freedom. Okay, the course that I am teaching requires or expects you, and the homework assignments that I have not written, expect you to calculate degrees of freedom in a very specific way. It's actually, in my opinion, somewhat unusual, but we're going to do it that way. Okay, so there are many ways. And almost always degrees of freedom, at least at this level, is calculated by n minus 1. But in this case, what we're going to do is we're going to see we have n equals 15, and here we have n equals 21. Well, we can't do both of them. We can't do both of them. So what we're going to do is we're going to do the smaller one of the two, okay? And the reason we're using the smaller one is a smaller degrees of freedom is more conservative. It gives us a more careful conclusion. So if we reject the null hypothesis on a more conservative number, then that's really good for our statistical support. So which one's smaller, 15 or 21? 15. So we're going to do 15 minus 1. So the degrees of freedom are 15 minus 1, which is 14. So there's our degrees of freedom, 14. Okay. And now we're going to say that we're going to reject H sub O if P, the P value, is less than the alpha, which is 0.01. Okay. Now, step 3, we're going to identify the critical T statistic for a right tail test based on an alpha of 0.01. So let me remind you, the way we're going to do that is in the NumWorks calculator. So we're going to go down to distributions. We're going to go down to students T distribution. If you recall, our degrees of freedom is 14, not 15. N was 15. N minus 1. 15 minus 1 is 14. So degrees of freedom is 14. So next, now we're doing a right tail test. So we want to come over here and hit OK when we want to go down to the right tail test. And then we're going to go over to the far right box and we're going to put in our alpha, which is 0.01. And that gives us a critical T value of 2.624494. Okay, so 2.624494. And so here's what we're going to say. We're going to say reject H sub O if, put this farther away, if The actual t statistic that we're going to calculate in step 4, if t is greater than our critical value of 2.624494. Okay? All right, so speaking of step 4, let's move on to step 4 and let's identify our standard error. Now, our standard error is going to be equal to the square root of S1 squared, so that's going to be 7 squared over n, which is 15, plus the other s, which is 4 squared over n, which is 21. Okay, I think I was a little too ambitious with the square root symbol here, so let's go ahead and shorten that up a little bit. There we go, that's a little better. So let's go to the NumWorks calculator and we'll calculate this. So we're going to go to the calculator portion, hit OK. We're going to do the square root of 7 squared divided by 15. And we're going to move over here and hit plus. Then 4 squared divided by 21. Let's make sure here. 7 squared over 15, 4 squared over 21. 7 squared over 15, 4 squared over 21. Good. And now execute, and our standard error is 2.00713. We can drop this 0 because it's not rounded, so 007 and then 13. So our standard error is 2.00713. Now to get our t statistic, we're going to do x bar 1, 75, minus x bar 2, which is 69, divided by the standard error, which is 2.00713. Okay, let's go to the calculator. We'll do 75, is that right? 75, yep, minus 69, close parenthesis, divided by 2.00713, and so our t statistic is 2.989343. So our t statistic is 2.989343. There we go. That's step 4. And now in step 5, we are going to take this t statistic and we are going to convert it into a p-value, okay, in the NumWorks calculator. And we did this back with the one sample hypothesis test, and the way we're going to do it is we have to go back to the distributions, okay. We're going to go back here to students t. Again, it's 14 degrees of freedom. It's the same question, same degrees of freedom. Next. Now, let's see what we're doing here. This is a right tail test, so we need a right tail. So we're going to need to come over here and select the right tail option. And then we're going to put in here, in the middle, we're going to put in our actual t statistic, 2.989, 343. And when we hit enter, our p-value will be over here in this box. And so our p-value is 0.004878. Okay, so our p-value is 0.004878. And now, here's what we can do. We can compare this to our alpha, 0.01. It says that we're going to reject H sub O if P is less than 0.01. Well, 0.004 is definitely less than 0.01. So we're going to reject H sub O, okay? Why? Well, because our p-value is less than 0.01. Also, look, our t, 2.989, is greater than 2.624. And so we can say also because t is greater than 2.624. 4. And we can put the other 494 if we want to, but this we get the picture. So we are rejecting H sub O, and now we're going to confirm it with a confidence interval. Okay, so we're going to do our confidence interval here. And the way we're going to do our confidence interval is we're going to take x1 minus x2, and then we're going to add and subtract the margin of error. The margin of error, remember, is going to be t star times the standard error. Okay, so let's do t star 2.624494 times the standard error, which is 2.00713. All right, so let's go to the calculator here, hit OK, and we're going to do 2.624494. That's the t star times the standard error, which is 2.00713, 2.00713, and our margin of error is 5.267701. Okay, so we're gonna wind up doing plus or minus 5.267701. Now we just have to do x1 minus x2. Well, we already have that. I think that was x1 was 75, x2 was 69, so the difference is 6. So it's going to be 6 plus or minus 5.267701. And so 6 minus this number, okay, so 6 minus 5.267701 is going to be 0.732. So just 0.732. So 0.732 is our 6 minus this number. That's going to be less than or equal to, then we put mu1 minus mu2. Check your notes. Check your notes. This is exactly what we're supposed to be doing. Now we're going to do 6 plus this number, okay? And one way to do that is to go back up and grab the one we just used and hit execute. Then we're going to go backwards and change the minus to a plus. And now we get 11.268. 11.268. And here's our confidence interval. Now, notice what is not on this interval. We have a positive number and a positive number. So, 0 is not on this interval. And since 0 is not on the interval, we reject H sub O, which is exactly what we did over here. We rejected H sub O. So the confidence interval has supported and confirmed our decision, okay? All right, what we're going to do now is we're actually going to run back through this question, only I am going to strictly use the NumWorks calculator to get some of this information. All right, so what I'm going to do right now is I'm going to show you how we can find the standard error and the t statistic in NumWorks. All right, so here we are in the NumWorks calculator. We're going to go down, and over next to the app distributions is an app called Inference. Now this is really useful. You're going to really like this. So we're going to hit OK on Inference. And look, it says tests and intervals. Wow, those are two of the things that we've been learning a lot about lately. Confidence intervals, significance tests, this is good news. All right, so here in tests, that's where we're going to find the t statistic. In intervals, that's where we're going to find our standard error. So let's do the standard error first. We'll go into intervals and come over. And which one are we doing? This is a lot of things. We're doing two means right now. Isn't that what we're doing? So go down to two means and go over. We're doing a t-test. So that's a t-interval. Hit OK. And don't use a data set. That's if you have the raw data. But we have statistics. Look, they gave us the statistics. So that's what we're going to do. We're going to input statistics, and we go in here and look, X1, sample 1 mean. Look, that's right here, 75. So we're going to put in 75, enter. S1, that's the standard deviation. Well, that's right here. That's 7. Great. Awesome. N1, the sample size from sample 1, that's right here. That's 15. 15. X2, X bar 2, that's the other sample mean. That's 69. So we'll put 69 in here. Sample 2, standard deviation, yeah, we have that. That's 4. Put a 4 in. And look, the sample size from sample 2, we have that too. That's 21. Okay, great. Now, confidence level. Confidence level. Now, we learned how to do this a while ago. We learned how to identify the confidence level maybe 7 or 8 videos ago. Given an alpha, we can find the confidence level. If it's a right tail test, we have to double the alpha. So alpha becomes 0.02 because 2 times 0.01 is 0.02. Then we're going to subtract that from 1. See, what we learned how to do is we had to do 1 minus 2 times the alpha, 0.01. And so 1 minus 2 times 0.01, that's 1 minus 0.02. Well, that equals 0.98, okay? And so what we're going to do is we are going to put in 0.98 for the confidence level. I don't even think we really need it, but we're going to put it in anyways, because I think all we need is the N's and the S's for the standard error. Next, and here it is. Look, there's the standard error, 2.0713. Just like we said, 2.0713. We were able to find it just in NumWorks without using the formula. We didn't have to use the formula. Now, the formula is not that hard, but if you want to do it in NumWorks, you can. Now, you may say, oh, hang on, I see some other things here, Mr. Ryan. I see the critical t-value is not the same one that you gave us. That's right. There's a very good reason for that. It goes back to the fact of the way we're finding degrees of freedom. This degrees of freedom is pretty complicated, and it's important. And if you go deeper into statistics and become a researcher someday, this is actually the version of degrees of freedom you will use. But we're not using this version, so ignore this degrees of freedom. Ignore this t-crit. Do not use this t-critical. You're going to find it the way that we did in the student's t-distribution. And that also means because this t-crit is wrong, or it's not the one we want, the margin of error is also incorrect. So when you come in here, only come in here for the standard error, okay? Now we're going to see how we're going to identify the t statistic by going into tests. If we go into tests, again, we're going to go down to 2 means. And again, we're going to choose t-test. Now, we have to select our hypothesis, okay? And if we go to this is our alternative hypothesis. Look, we have 3 choices: less than, not equal to, or greater than. So we just have to pick the one that goes with our test. We're doing a right tail test, so we're going to choose greater than. If we were doing a left tail test, we would choose this one. If we were doing a 2-tail test, we would choose this one. But we're doing a right tail test, so we're going to choose this one, okay? See, we have the greater than. Now we're going to go down to next, okay. We're going to input statistics. We're going to put the same ones in: 75, 7, 15, then 69, then 4, then 21, okay. And now it asks for the significance level. Now we can put the correct significance level in because it knows it's a right tail test. And then we're going to hit next, and there's our test statistic. 2.989343, 2.989343. And so I just wanted to show you, and let's see if the p-value is correct. No, the p-value is different, and it's because the degrees of freedom are different, okay? But the t-test statistic, it is the same. So I just showed you how you can identify the standard error and the t-statistic just by going into the inference feature in the NumWorks calculator, okay? All right, that's it for this example. We're going to do one more example, and in that one, I'm actually not going to calculate the standard error, and I'm not going to calculate the t-statistic. I'm just going to get them right out of the NumWorks calculator.